Yeah, good morning to all. Please, good morning. Yeah, Bhavana, good morning. Okay. In previous sessions, we have seen regular languages as well as we started the context-free languages. I think you are getting to know about CFLs. Of course, it's a long journey that you need to practice much about the PDA construction and context-free grammar writing. Then you will get to know what are context-free languages. Okay, but still we'll see many standard examples, and sometimes you may see these examples directly in the exam. Sometimes you need to understand the given languages also. Okay, good morning to all. Juleka, Saurabh, Anish, good morning. I hope you are doing homework questions. So when you do homework questions, right, you will understand what we are doing it. See, you are attending the classes and then you are not doing homework questions. It may not be complete. So if you do them, you will get doubt. You may ask later on. So that is the process of learning. Okay. Yeah. Arsh, Lalit, good morning. Arish, good morning. Ashi, good morning. Okay. So in this session, we will continue the CFLs, but also we will include the closure properties. To know, like in regular languages also, वहाँ पर भी closure properties apply किया था. Similar to them, we will also look at the closure properties on context-free languages. So CFLs, now in this session, you should know about context-free languages, and also you should know the difference between DCFLs and CFLs. The most of the students, okay, some students have a clarity. Most of the students, they do not know when we call them as DCFLs and when we call them as CFL, but not DCFL. See, you should know clear relation between these two. We'll see that. And also closure properties, we'll have some practice on languages too. Okay. Good morning, Shine. Okay. Let me discuss two important problems before identifying CFL and DCFLs. One problem is A power, I have given homework, I guess, C power K such that M is equal to N or N is equal to K. Now look at the string. Suppose I have triple E and B, I don't know what is after. Now this triple A, let's say you pushed it. So on the stack you will be having Z0 by default, and you push 1A, 1A, 1A. Now this B, what we should do it after completing this 3A scanning, this B, what to do? Should I push? Anyone? तो ये समझने के लिए आपको डिटर्मिनिस्टिक पीडीए पॉसिबल नहीं है, नॉन डिटर्मिनिस्टिकली करना होगा. क्यों? डिटर्मिनिस्टिकली अगर बी के लिए ये पॉप किया है तो ये कंडीशन चेक कर रहा होगा. अगर बी पुश किया है, हो सकता है एन इज इक्वल के चेक कर रहा होगा. तो ये बी के लिए सिंगल चॉइस नहीं होगा आपके पास, है ना, डिटर्मिनिस्टिक चॉइस नहीं होगा आपके पास. अगर पॉप किया है तो स्ट्रिंग हो सकता है. यार यहां दो पॉसिबिलिटी है. देखो ये जो स्ट्रिंग दिख रहा है ना, तो फ्यूचर का तो किसी को नहीं दिखता है. क्यों है? यू आर एट दिस बी एंड यू डोंट नो व्हाट इज द फ्यूचर. नाउ यू कैन नॉट डिसाइड व्हाट इज माय स्ट्रिंग बिकॉज टिल once you reach the end, you know that the string is valid or not. At this point, you do not know what is a string, but you should try to reach the final. So now look at your string might be triple A, triple B, 1C. That might be satisfying M is equal to N, or your string might be triple A, double B, double C. Your string might be satisfying this condition. Now tell me, what should I do on this B? I am at this point. I don't know about my future, and tell me what should I do. This string, I have two possibilities. Other possibilities is invalid string. Invalid string, anyhow, we don't have a path to the final, so we don't care. Correct? So now I have two possibilities for the valid string. Now, if my string is having 3 B's and 1 C, now for B I need to pop 1 A. And if my string is having 2 B, 2 C, then I need to push the 2 B's. I need to compare with the 2 C's. Tell me what to do. And for this B, what should I do? I know this 3A, I pushed it. Correct? This 3A, we pushed it. We did a one job, right? This is my string. Now I don't know what is future. For this B, what should I do? You cannot do two things at a time. Only one choice, but you have two choices. Two things at a time you can't do. So you should take the choices. Non-deterministically, you can take two paths, and you can look at the two different valid strings in two different paths. Okay, yeah, there is no pop and push. You don't know what to do. Now what to do? We don't know. We have two choices. How many choices we have? I'm already informing, right? I'm already helping you. We have two choices. We don't know exactly. This B's might be equal to A's, or this B's might be equal to C's. We have a problem. We have a problem with this B's. This B's might be equal to A's or might be equal to C's. We do not know. That is a problem. This is the main problem why we cannot call deterministic context-free language. Suppose if I give you A power n, B power n, C plus, it's very clear. For A's you push, for B's you pop A's only, and for this is just skip, don't do anything on the stack. Very easy to do this. See, for A's you push A, for B's you pop the A's, for C you just skip, at the end you should see the Z0 on the stack. That's all. This is the logic. But in the previous case, you are not knowing that B is it equal to A's or B is it equal to C's. You have two conditions. There is R. You are right. If it is and, anyhow impossible to do with the stack. Now, to accept this valid strings, there are two valid strings. You see it in the first two. This first three A's, in both the strings are same. Now this B, I need to take a choice, deterministic choice, but impossible. So we have non-deterministic choice. So for this B, we have two choices. Two choices. We may pop A or we may push B. These are the non-deterministic choices. You are not telling exactly what to do because you cannot build a deterministic PDA for this. That's why this language is not a deterministic CFL. Okay, it is not having DPDA. You can only build PDA. What you can build? PDA. So now I'm going to build a PDA for this. Of course, it's easy to design. Just look at how to build it. From Q0, we can push all the A's, and simply you can do this. You need to say Z0, A. Anyhow, you don't have a deterministic motion, right? You can do simply A comma epsilon slash A. That means every A you push it. That's it. Every A you push it. Is it? You are not applying PDA, you are designing PDA, right? He is saying that when to apply PDA. You don't apply PDA, you design a PDA, because deterministic PDA is, you can't understand this one. For A you push A, for B what to do, you are not clear. That is what non-deterministic PDA required. Okay, A you can push, now B what to do. Now we have a problem. If of course, let's take one condition for easy. M comma N comma K greater than or equal 1. In this cases, only A's or only B's or only C's will not come. That's so easy to design. Now definitely one A should come, definitely one B should come, definitely one C should come. And how many A's, how many B's, how many C's, we don't know. Now, if B comes, A should be there on the stack. But can you take a single decision? No. This is called as a non-deterministic PDA. This is called as, see, same input and same top of the stack, you are not able to decide what to do because you don't have a deterministic operation. Now, you can't say push, you can't say pop, then I have two choices. We may pop the A to satisfy this one, we may push the B to satisfy this condition, because there are two kinds of strings which can follow the same sequence. Now, what you do? B comma A. If you want to check m equal to n, you have to pop to check m equal to n. If you want to check n is equal to k, you have to push it, BA. So this is the push operation. This is the pop operation. So I have two paths to satisfy two different valid strings. Now, after that is so easy. Now you decided m is equal to n, then you decide, how to check, these two are equal, and then C's you skip all of them. So now B comma A pop. I don't know how many A's, how many B's are going to come. Just pop all the A's for every B. If these two are equal, then when C comes, Z0 only there. What should be there? When C comes, what should be there? Z0. This combination will tell us these two are equal. If they are not equal, then you might check other path, because it's a non-deterministic machine anyhow. What you do? Just skip every C, and then go to final. Skip every C. When end of the input comes, and on Z0, you may keep a Z0, but go to the final. Now you see, push A's and pop the A's, and then skip the C's, and then go to final. So one kind of valid string which can satisfy m is equal to n. And next, another one, n is equal to k. When to design, language will tell us, Zulekha. This is the case when you design a PDA, right? This is how you design a PDA. For this language, you have two conditions, and one condition is checking A's and B's, other condition is checking B's and C's. You don't know, the string might satisfy A and B, or string might be satisfying B or C, but B is the common to both conditions. And for B, you want to compare with A, don't know. You want to compare with the C, we don't know. You two choices need to be covered in the same machine. If the string is valid, this side may be halting at final, this side you will have a path to the final. If the string is other valid string, this side you will be having a path to the final. NFA, you remembered, if it is NFA, at least one path exists to halt at final. The same way, if the string is valid, either this side or this side, you will be having a path to the final. Okay, so for B, now you need to push it, because you want to compare with the C. If you want to compare with the C, B you have to push, and C you have to pop the B. Now every B, you need to push it. The first time only BA, later on the B is there on the top of the stack, you push every B. When C comes, you have to pop the B, because this side you are comparing C and B. Right? You pop every B, and if the C's and B's are equal, when the end of the input comes, what should be there? A definitely there, because all the B's are deleted, and keep the A and go to the final. Now first understand the language. A language will tell us when to design a PDA. We cannot decide on our own. The language decides. You need to understand, is this language possible with the deterministic PDA? Deterministic means this B comma A, you cannot take the two choices. Take one or no choice, that's it. Now B comma A, if you take only this one, if you don't take this, you are designing. See this one is deterministic PDA. DPD exists. How? For A you push, for B you pop the A, for C you skip. You are not taking the two choices for any symbol. So DPD exists. When DPD exists, PDA always exists. Okay. Two final, not required. It's your choice. One final, two different paths are there. It's not about two finals. You can take your two finals there. Nobody worries how many states you design. 100 states you design for the same problem. Nobody worries, because we have a logic single for every context-free language. With the one state also you can design. You have an algorithm, you write a context-free grammar, convert to PDA, always one state exists within the PDA. right? You don't worry about how many finals. It's not a finite automata, right? You need a minimum number of states. Nobody asks in the world how many minimum number of states required in a PDA. Nobody asks, right? You should understand. You should understand. I hope सबको समझ में आया होगा, right? This is how you design a non-deterministic PDA. Done. That you don't design in the exam. You need to understand every step that I am explaining through example, through problem, why you have two different choices for the B. If this B, you are only popping the A, then you can't accept the strings which are n equal to k. That's a problem. Okay. Now you may ask the doubt. If you don't want it, don't take it. You can write, that's your choice, right? If you don't want this, don't write it. You write your own normal condition. 100 ways are there to push the A's. The one way is this one. One way is this one. Other way is, why do you waste your time? Already it's a non-deterministic, right? Why are you telling Z0 is there, then A is there? These two things you can replace with the one thing, that is A comma epsilon. Understand, single transition. A comma epsilon slash A. It means push A without looking at the stack. Anyhow, we know Z0 is there, then A is there. You know that. It means push A. And you are wasting your time to design a PDA. Already it is non-deterministic. Instead of saying that A comma Z0, A Z0, the first A, the second A is A comma A slash double A. These two things can be done by this one thing. So it's easy to do it. Okay. बात क्लियर? ये दोनों है डिटर्मिनिस्टिक ट्रांजिशन से. ये डीपीडीए में ये नहीं कर सकता, बट ये डीपीडीए में करना चाहिए. ये दोनों में कर सकते. पीडीए दोनों, राइट? ये दो चॉइसेस है, पीडीए में कर सकते हैं. आप दो इंडिविजुअली लेना है ले सकते हैं, और एक ही लेना है दोनों के लिए. पीडीए में बहुत सारे पॉसिबिलिटीज है. क्यों? आपको पता है क्यू क्रॉस सिग्मा क्रॉस गामा होता है. क्यों डीपीडीए में? यार पीडीए में क्या है, सिग्मा है, एप्सिलॉन, गामा के साथ एप्सिलॉन चाहिए तो एप्सिलॉन भी ले सकते, स्टार भी ले सकते. तो बहुत सारे चॉइस होता है पीडीए के लिए. ठीक है. पीडीए का डेफिनेशन थोड़ा बदल के भी इस तरह लिख सकते हैं आप. तो आपकी चॉइस है सर. या डिटर्मिनिस्टिक पीडीए में ऐसे ही लिखना होता, पीडीए में ऐसे भी लिख सकते हैं. तो ये इजी है पीडीए डिजाइन करने में. तो इसलिए बहुत लोग को प्रॉब्लम होता है पीडीए समझना. राइट? अब तक तो डिटर्मिनिस्टिकली कर रहा था, अभी नॉन डिटर्मिनिस्टिकली कर रहा है, तो कंफ्यूजन स्टार्ट होता है. PDA design, you don't design it, they will give you, you need to understand it. If you don't understand this, how will you, right? If you cannot design it, you cannot understand. That is a very simple funda. If you can understand it, that means you are already designed it. Got it? So first understand how to design it. In the exam, whatever they give it, you will understand easily. So this is a very easy question, right? Okay. In the exam, what do they ask? They will give you language. How will you tell you is it CFL or not, DCFL or not? You need to know construction first. The previous problem was CFL but not DCFL. How can you identify? What is this language? Is it regular? No, it's not regular. Is it DCFL? No. How do you know it? When you know how to design it, you will know it is not a DCFL. Is it CFL? Yes. So in the exam, how do you identify it is CFL but not DCFL? How do you know that? If you practice this kind of motions, then you will get to know it is a CFL which is not a DCFL. To answer it, you must construct a PDA. Those people who spend the time to construct the PDA, they can identify it is a CFL but not DCFL. Okay? There is no shortcut. There is no shortcut to identify directly. You spend more time, you may find the shortcuts. But for learning, there is no shortcut here. Yeah. Good morning, Roshan. Every time you don't find a shortcut for every language. Okay. Okay, next. Now with this, you don't understand directly by looking at it. You can see it. And I'm going to give you some languages. You just identify. Okay. Identify languages. Okay. This is your job now. Identify languages. The first language. What do you need to identify? Option A, regular. Option B, DCFL. Option C, CFL. Option D, even not CFL. Okay. Let's try the first language. A power n, B power n. Quick. Okay, now you will get to know how to relate the DPDA and PDA. So what exists for this language? Both exist or only one exists? If it is DCFL, you should say CFL, right? So you should not leave just DCFL. Every DCFL is also CFL. If you have a DPDA, you also have a PDA. That's why when you design a DPDA, you can also design other way to design, accept the same language. So every DPDA is already PDA. Okay. So it is DCFL. We know it is not regular. So it is DCFL and also CFL. Every DCFL is a CFL. You cannot just live with the DCFL. Okay. If it is MSQ question, if these two options are there, you have to choose both of them because it is DCFL. You have a DPDA. How do you know it is a DPDA? Now you should know one thing. How do you know it is you have a DPDA? Just look at the sequence. A's comes, what do? You will push them. You don't have a confusion. Should I push or pop? You have unique choice. I have to push A's. Only one choice. And B comes, what do? Only one choice. B, pop the A. See, for this A, you push. For this base, you pop. Did you take the two choices? No, right? Previously, when you look at the string, you see that. Now, when I get a B first time, I was not sure should I go this side or this side because I have two different conditions. My string might satisfy this or might satisfy this. I don't know. That's why we took the two choices. Yes or no? Now for B, if you take the pop, that means there is a different language, not this language. But I may take the pop A or I may push B. This is called as non-deterministic choice. This will never be called as a deterministic choice. Okay. If you can take deterministic choice, that language can be guaranteed DCFL. Okay. Now here you can do deterministically. Every deterministic is non-deterministic, so you can also call CFL. Okay. Don't say that it's not possible using non-deterministic. Yes, possible. See, what we did was DPD earlier. Now you can also do other way. See here, A epsilon A and epsilon comma epsilon comma epsilon B comma A epsilon, and when the end of the input comes, Z0 only there. And see, this is another way to do PDA. You have a DPDA and that is already PDA, but PDA you can design another way. See that? Now I did not design DPDA. This is not a DPDA because already it is a DCFL. So CFL, I can also design another PDA for this. See this A epsilon, without looking at the stack I can push the A, and without reading input, without looking at the stack I can jump here, and B comma A, for every B I can pop A, and when end of the input comes I have to see the Z0 to reach the final. This combination happens only when if these two are equal. Did you see that? I did not design a DPDA. Even though it is a DCFL, I no need DPDA because every DCFL is a CFL. I can design a PDA for this. Everyone clear? So very important, this kind of questions may come in the exam. If they give this language, you should know this is A power n, B power n. Getting my point? What is the language accepted by this PDA? It is not a DPDA, it is a PDA. And what is the language accepted by this? DCFL. Which DCFL? A power n, B power n. Clear? Very, very important. This kind of questions you may face in the exam, like they may give you PDA or they may give you DPDA, and you should know what is happening here. This is push A. It's just jumping from this state to this state because you're not reading input, you're not looking at the stack, you're doing nothing here, and after coming here, every B you're popping A, and if that does properly, when end of the input Z0 comes. Because how do you know this is end of the input? Because from this state you don't have any transitions. If you don't have a transitions, this has to be end. So this epsilon is very special. It represents end because after this there are no transitions. Yeah. What do you want to define? If long expression given, then what do you want to define? Tell me what do you want to define? Okay. Question 2. A power n, B power n, C star. A power n, B star, C power n. Quick. Is that expression? B power n you can replace with B star, that is a regular expression, so regular language. If it is a regular language, that is a DCFL, then CFL. Use your brain, what you are writing and what you want with that, okay? You are writing regular expression, then it is the regular language. Every regular expression generates a regular language. If you can write a regular expression, that means it generates regular language. All are same answers? All. But the concept, the way you design DPD is different. Here A's you push, B's you pop the A's, C's you skip, right? You should know the logic. Here A you push, B's you skip, and C's you pop the A's. And this one, A's you can skip or push. We don't care. That's you take anything, but only do one, not like choices. Yes, take the one decision. Skip. B's push. C's pop the B's. Okay. There are many ways to design a machine. There are many logics. Okay. Every symbol you can take a single choice to decide. Correct? Fifth. A power m, B power n, C power k. Now you take m is equal to n or m is equal to k. This is a different problem. A power m, here m is equal to 2n or n is equal to 2m. 7. Yeah. So in the exam, that's all they give this one. They don't ask mostly PDA. They ask identify the language. So when will you identify this? If you work on construction, then you can easily identify it. It's not that easy. If you don't spend the time to construct the PDA or DPDA, it's not that easy to explain or it's not that easy to choose. Okay, आपको ये समझ में आना चाहिए, ये जो लैंग्वेजेस है आइडेंटिफाई करने के लिए, तो आपको लॉजिक समझ में आना चाहिए, ये इस पे क्या करना है, या पुश करना है, सपोज पुश कर लेना, तो 20 के लिए क्या करना है, तो इसके लिए क्या करोगे, पुश, ठीक है, क्यों, या कंपैरिजन तो है तो पुश तो करना है, बट बी के लिए क्या करना है, स्किप करना है, पॉप करना है, तो दो चॉइस है, अगर पॉप किया है ना, हो सकता है ये ए एंड सी इक्वल है, तो जब बी पॉप किया ए के लिए, तो सी कैसे कंपेयर करेगा, ए को नहीं कर सकता, तो बी पर दो चॉइसेस लेना है, अगर m इक्वल n करना है तो यहां पर पॉप एस करना होता, अगर n इक्वल k करना है इसको स्किप करना होता, तो इनके लिए दो चॉइसेस लेके जाना होता, स्किप, डू नथिंग और पॉप द एस। तो अगर पॉप एस किया है तो चेक करना होता है ये दोनों इक्वल है नहीं है, अगर इक्वल है जब सी आया तो जेड नॉट होना चाहिए स्टैक के ऊपर, तो सीज को स्किप करेंगे इस तरफ, अगर उस तरफ गया तो 20 को स्किप किया, उसके बाद सीज के लिए एस को पॉप करना होता, एवरी सी यू पॉप द ए एंड एट द एंड द सी एंड ए इक्वल होना चाहिए, ठीक है। ये है CFL but not DCFL. CFL है but not regular, not DCFL also. और ये जो यार देखो आइदर A ट्वाइस होगा और B ट्वाइस होगा कंपेयर टू A. तो यहां देखो दो चॉइसेस है, नंबर ऑफ A's इज ट्वाइस टू द B's और नंबर ऑफ B's ट्वाइस टू द A's. यार इनके लिए भी दो लॉजिक चाहिए होता. अगर एवरी ए पुश वन ए तो एम ए स्टैक में है तो हो सकता है ये हाफ ऑफ द बीस, नहीं तो डबल टू द बीस. तो ये कैसे चेक करेंगे हम? तो इनके लिए भी दो अलग अलग पाथ लेके चेक करना होता. ये भी CFL बट नॉट DCFL होगा, है ना. और ये जो ऑलरेडी कंसिडर किया है ए DCFL है तो CFL भी होगा. अब ये 8 जो है इसके लिए कोई DPDA नहीं है. देखो इस दोनों में डिफरेंस क्या है? एश जो है वो बता रहा है W पावर R कहां एंड, W कहां एंड होगा, W पावर R कहां रिवर्स होगा. तो यहां नहीं पता तो क्या करना होगा आपको? एक ऐसे नॉन डिटरमिनिस्टिक मोशन डिजाइन कर सकते हैं. W के लिए A डिजाइन करना, ये W पुश करने के लिए थोड़ी देर के बाद स्किप कर दो, मतलब कुछ नहीं करना है, स्टेट चेंज करके रिवर्स आप चेक करो. रिवर्स W कैसे करते हैं? बेसिकली एवरीथिंग यू पुश. एवरीथिंग कैसे पुश करेंगे? A कामा जेड नॉट, A कामा A, B कामा जेड नॉट, B कामा A, A कामा, सब सारे कॉम्बिनेशन. इसको हम सिर्फ दो से कर सकते हैं, A कामा एप्सिलॉन, B कामा एप्सिलॉन. तो ये दोनों क्या करेगा? एवरीथिंग A एंड B पुश करेगा. थोड़ी देर के बाद चेंज करके क्रॉस चेक करेगा. अगर रिवर्स सही आप अज्यूम किया है तो ये क्या करेगा? रिवर्स को पॉप कर देगा. ठीक है, A कामा A, B कामा B. अगर ये दोनों सही है, W यहां पर है, W पावर R यहां पर है, तो एट द एंड जेड नॉट दिखेगा स्टैक के ऊपर. ये नॉन डिटरमिनिस्टिकली डिजाइन कर सकते बट डिटरमिनिस्टिकली इम्पॉसिबल है, इसलिए ये CFL है बट नॉट DCFL है. ठीक है, ये 8th होमवर्क दिया है, आई होप ट्राई किया होगा. डिटरमिनिस्टिकली इम्पॉसिबल है इसके लिए, तो इसके लिए बहुत टाइम लगता है एनालाइज करने के लिए. यस, एवरी DCFL इज CFL. No, Bhuvana, R doesn't mean that it is not DCFL. ठीक है, R doesn't mean, that's a wrong assumptions. Okay, रेगुलर भी हो सकता R होगा तो. देखो R क्या यार, तो समझना होगा. You have to think it. M equal to N और M not equal N. अब बताओगे ये CFL? Of course CFL है, but रेगुलर भी है. This is nothing but ये स्टार B स्टार, ये रेगुलर है यार. तो बात को समझना, लैंग्वेज को समझना, कंडीशन को नहीं देखना. ठीक है, इफ द लैंग्वेज इज हैविंग और इट इज नॉट DCFL, गलत है. ठीक है, ये तो आर है बट नॉट DCFL नहीं बोल सकते, ये DCFL तो है. ठीक है, यू हैव टू अंडरस्टैंड द लैंग्वेज, नॉट जस्ट लुकिंग एट द कंडीशंस. Of course, when you keep on practicing, you will get to know which languages are regular, which languages are DCFL, which languages are CFL. By practice, you can easily identify them, because in the mostly in the GATE exam, undergraduate students, they know it. Every language they cannot understand. So they just look at the standard examples from this chapter. What you learn, always standard examples. If any small modification to them, easily you can understand. Okay, they don't create many difficult languages, remember this. So far in the history of the GATE exam, they asked very easy questions, but there are still difficult questions they did not try it. Okay, so some of the points like every regular, you cannot confuse them. If it is regular, it has to be DCFL, it has to be CFL. So understand this point, every regular is CFL, even DCFL. Every regular is also CFL, right? Every DCFL is CFL. You cannot say regular, may or may not be regular. DCFL may or may not be regular. Every finite set is a regular. Finite language over the sigma. Every finite language is also DCFL. So these points you cannot ignore it. Okay, how many? 9 problems over 10. A power prime, we know it is not regular, But now what is it? Is it DCFL or is it CFL or none? Quick. So there is one interesting point here. यहाँ पर एक और interesting point है. ये language over one symbol है ना? This language over one symbol. All these three languages are over one symbol. Yes. Language over one symbol, अगर ये non regular है और पीडीए भी नहीं कर सकता, अगर ये फाइनाइट नहीं कर सकता तो पीडीए भी नहीं कर सकता. ये बहुत अच्छा से एक रिलेशन है. एवरी नॉन रेगुलर इज नॉट सीएफएल. बहुत खतरनाक स्टेटमेंट है यहां पर. तो एक नोट लिख देते हैं हम यहां पर. नोट, वेरी इंपॉर्टेंट नोट. एग्जाम में ये डायरेक्टली भी आने के लिए चांसेस है. इफ L is over one symbol, then L is regular if and only if L is CFL. Of course, DCFL also you can add. That means this statement has all the things. L is not regular, then L is not CFL. L is not CFL, then L is not regular. It has almost 4 statements here, 4 statements. So this statement has A implies B and B implies A and not A implies not B implies not A. There are so many statements in this just single line. If you study discrete mathematics, if you studied that P if and only if Q, how many statements are there? P implies Q is there, Q implies P is there, not P implies not Q is there, not Q implies not B is there. That this kind of answers can be derived from the single line. Okay, so this is a very important statement. If L has a finite automata, then L also has a PDA, no doubt. If L is not having a finite automata, then L will not have a PDA, because it just depends on arithmetic progression. With if you can do, you can do with the cycle. If you can't do, even stack cannot help you. Okay, you might wonder, sir, why A power prime is not having a PDA? Okay, why A power prime? See, only A's are coming, right? When will you use a stack? At least somebody should be there to write separate. If you have this one, you can use the stack to push A's and pop the A's. Now only A's are coming. Tell me when to push and when to pop. At least you should have 2 different symbols. So one symbol you can push, other symbol you can pop. Here only one symbol comes, then you will not understand. There is no use of the stack. If the language is having only one symbol and the string is having only one symbol, there is no use of the stack. When there is no use of the stack, finite automata and PDA will be equivalent. Right? You are not using the stack at all, right? The stack will never help you to understand this kind of only one symbol concept. So all of them are, what are they? We know they are not regular. Not only not regular now, they are also not a DCFL, they are also not a CFL. Then what are they? They are actually context sensitive languages. Okay, you need Turing machine linear bound automata concept to understand them. Right. All the regulars are DCFLs, so that's one concept is very clear. If you have a finite automata, you can design DPDA, you can design PDA also. Okay. So now you focus on all the gate questions, try to identify them. Of course, it takes time. See, I have helped you some languages, right? How many languages? Nearly 12. And still, yesterday we did some questions, right? You can also practice them. You have already so many languages which are regular, non-regular. Take them and identify which are CFL and not DCFL. You have homework. What is the homework? Go to the regular language chapter, and we have discussed regulars, non-regulars. All the regulars are DCFL and CFL. That's okay. And non-regulars, take them and identify them. I didn't get you, Ashu. Except regular, it can be DCFL. What do you mean by that? Now take the non-regulars, find out are they DCFL or CFL or not CFL. That's your homework. Okay. Some languages also will do before going to the closure properties. Not CFL will take. Can somebody try to understand these languages? A power n, B power n, C power n. A power n, B power n square, C power n cube. A power n, B power 2n, C power 3n. A power n, B power n factorial. All these languages are impossible with the help of stack. They're all not CFLs. If they're not CFLs, definitely not regulars, not DCFLs. They're context sensitive, true. Why they are not CFL? Because one stack cannot help to compare the three symbols at a time. Like A and B, if you compare, you cannot compare C with the B and A. And if you compare B and C, you cannot compare A with other. So stack can help you to, check the two symbols dependency only. In all of them, you have such things. But last one, the n factorial already impossible with a stack. That's why you cannot compare these two. Okay, this other interesting languages, for them the stack is useless. Stack cannot help to check. They are all context sensitive languages. You can write a note if you want. All are CSLs. All these are context sensitive languages. 13 to 16. Of course, so far whatever we have seen, all are context sensitive, because every CFL is also CSL. Okay. So let's move to the another list. Very important list again. Closure properties. Okay. Let's take one by one. Union, intersection. This could be possible in the exam directly. Again, these operations are very important. We'll take two separate slides for the same. Yeah. First operation is, let's say, union. Just think about it. This is for DCFLs, for domain having DCFLs, for domain which is having context free languages. Intersection, three complement. First three always important for the exam point of view. Remaining depends. They may or may not ask, but first three always important. Complement, difference. Difference you can easily understand by taking the help of these two. Concatenation, then reversal. First you can try on your own DCFL union DCFL. What will happen? Union DCFL. Is it DCFL always? Think about it. So we have two columns here. One column also specifies closed or not closed. Okay. Yeah. Started answering it. Union, intersection. What will happen? And this side is answer closed or not closed. This side I need exact answer. What happens if I do them? Two DCFLs, if I do intersection, what happens? DCFL complement, what happens? DCFL's difference and DCFL's concatenation and reversal of DCFL. Okay, similarly, you also answer for CFL. CFL1 union CFL2. CFL complement. These are in general statements. If the particular language is given, you should give exact answer. What is the DCFL union? The first one, and remember that this table may be useful directly in the exam, because they simply ask one of them, intersection of two CFLs in general. Then you can get from directly this table. First one, may or may not be DCFL. May or may not. May or may not. DCFL. That's why this answer is not closed. So these two are dependent. Remember, the result of this one will decide is it closed or not closed. Intersection of two DCFLs, again same problem. That's why not closed. Question mark means either inside or outside. Inside means DCFL, outside means not DCFL. This column talks about is it a DCFL or not. Result, is it DCFL or not. If I put the question mark, remember it, it's a may or may not be DCFL. If I put the question mark here, may or may not be CFL. So based on the column, the question mark meaning is changes. Okay. Now DCFL complement, always DCFL. That's why it is closed. Keep this point very special for the DCFLs. Complement of DCFL always DCFL, but union of two DCFLs may or may not be DCFL. Intersection also may or may not be DCFL, and difference may or may not. Concatenation may or may not. Reversal may or may not. So that's why remaining all are not closed. But if you want to know the reason, then definitely you should find the counter examples. Okay. And many people do not know concatenation of two DCFLs is DCFL or not. Need not be DCFL. Some examples will get a DCFL, some examples will get not DCFL also. Okay. And here again, anything could happen, anything could happen, anything could happen, anything could happen, and this is always CFL, and reversal is always CFL. Oh, I'm sorry, CFL, I'm very sorry, is always CFL. Only intersection, anything could happen. Okay, that's why this is closed. And what is another one closed? These three are, of course, no, closed. Closed. Now you have the proofs why they are closed. Right. DCFL is not closed. It's not closed, yaar. Nageshwar, it's not closed. Regular, everything is closed here. You don't worry about regular. Regular already done. All of them are closed. All of them are closed for the regular. For DCFL only, you look at only complement is closed. Only complement from this list. Remaining all are not closed. But union of two CFLs is a CFL because you can design a two PDAs, you can combine them very easily. You can write a two context free grammars, you can combine them very easily. Like similarly, concatenation, reversal, you can prove with the help of context free grammar. That's why they are so easy to remember. Union, concatenation, reversal, you can easily prove with the context free grammar. But intersection of two CFLs is need not be CFL. That's why it is not closed. Complement is also need not be CFL. Sometimes, sometimes not. Now here what is important? Intersection. Intersection is very important for context free languages. And it was asked nearly 3 times in the exam so far. How many times? 3 times in the exam so far. CFL, intersection, CFL is dash. In general, answer is need not be CFL. It means you have 2 kinds of examples. Like case 1. If I take A power n, B power n, intersection, same language I take again, you will get a CFL. But if I take A power n, B power n, C star, intersection, A power k, B power I, C power I, then you see here AB equal, here BC equal is, you will get not CFL. Why? You will get a result A power n, B power n, C power n, you will get all 3 equal. This is a context sensitive language. So that is the reason intersection of 2 context free languages may be CFL or may not be CFL, right? These 2 examples, and this example was asked many times in the exam. Okay, complement. Complement is closed for DCFLs, yes. Done. So for every not closed, you will see the reason case. You can see the 2 cases for every not closed in the previous table. One example you can, this no need to remember. Case 1, see, you can take regular, intersection, regular. So regular is CFL. So this one is not a problem. Case 2 is very important. For which example, after performing operation, you will get not inside the domain. This example is very important. Union of DCFL. Okay, yeah. If you can try yourself here. DCFL, union DCFL. What is the answer? May or may not be. DCFL. But remember, there is one more point, but always CFL. You get always CFL, no matter which 2 DCFLs you take. Case 1. You can take regular or anything, right? A power n, B power n. Take the same thing. What do you get? DCFL. But I want to prove may or may not. So maybe DCFL, may not I will prove. A power n, B power n, union. I will take here A power n, B power 2n. This is not a DCFL, but it is a CFL. What is the language you get here? If you combine these 2, what is the language you get here? You will get A power I, B power j. This one both are equal, I is equal j, or this one j is twice to the 2i. Now one says, one kind of string says both are equal, other string क्या बोलता है यहाँ पर? तो b जो है twice to the a's, तो ये बोलता है. Is it clear? जो यूनियन ऑफ 2 DCFLs है वो DCFL हो सकता और नॉट DCFL भी हो सकता है, वो एग्जाम्पल डिसाइड करेगा. बट इन जनरल अगर ऐसा स्टेटमेंट दिया है L is a DCFL, L1 is a DCFL, L2 is a DCFL, L1 union L2, क्या होगा? कुछ भी हो सकता है. बट L1 is this one, L2 is this one, आंसर क्लियर होगा, आंसर नॉट DCFL होता है. यहां नीड नॉट बी DCFL नहीं बोलना है. जब 2 एग्जाम्पल्स दिया है तो आंसर एग्जैक्ट होगा. रैंडम इन जनरल स्टेटमेंट दिया है तो आंसर ये होता है. तो देखना नॉट DCFL कब बोलना है, मे और मे नॉट बी DCFL कब बोलना है. तो बहुत लोग को ये दिक्कत होता है, नॉट DCFL बोल देता डायरेक्टली. नहीं बोलना चाहिए DCFL यूनियन DCFL, नॉट DCFL नहीं बोलना है, क्योंकि जनरल स्टेटमेंट है. तो कभी कभी DCFL होगा, कभी कभी नॉट DCFL होगा. सबको सेटिस्फाई करने के लिए मे और मे नॉट बी DCFL बोल देते हैं हम. ठीक है, बहुत इंपॉर्टेंट है. ठीक, इस टेबल को कोशिश कर लेना याद रखने के लिए। अगर किसी को भी प्रूव करना है यार, रेगुलर क्लासेस में तो हम एवरी ऑपरेशन को एक्सप्लेन कर लेते। अगर नोट्स आप ग्रुप में हो तो नोट्स डाउनलोड करके आप पढ़ सकते हैं। अगर नोट्स देखो पढ़ना है तो आपको पता है, ग्रुप का नाम तो ऑलरेडी पता है। अगर कोई भी नया है यहाँ पर, देवस सर PW, ये टेलीग्राम ग्रुप में ज्वाइन करके आप कर सकते हैं काम। ठीक है, और नेक्स्ट कितना हो गया, 6 ऑपरेशंस हो गया। बस ज्यादा एक्सप्लेन नहीं करूंगा और कोशिश करेंगे इंपॉर्टेंट वाला। एक और है क्लीनी स्टार और क्लीनी प्लस, दोनों सेम है तो क्लीनी प्लस नहीं लिख रहा हूं मैं। ठीक है, तो ज्यादा कवर करने के लिए सबसेट, प्रीफिक्स, सफिक्स, सबस्ट्रिंग। ठीक है, सब्स्टिट्यूशन 13, इनवर्स होमोमॉर्फिज्म, होमोमॉर्फिज्म, सब्स्टिट्यूशन एंड होमोमॉर्फिज्म यहां लिख देते हैं, दोनों सेम है ना ऑलमोस्ट। किसी को ये पढ़ना है एग्जाम में, ये हो सकता इनवर्स होमोमॉर्फिज्म क्लोज्ड आर नॉट, तो यहां से आप कर सकते हैं। तो डायरेक्टली आंसर लिखेंगे। अभी DCFLs के लिए ए कॉलम यूज कर लेते, CFLs के लिए ए कॉलम, डायरेक्टली क्लोज्ड और नॉट क्लोज्ड। ठीक है, फर्स्ट वन क्लीनी स्टार नॉट क्लोज्ड, सबसेट नॉट क्लोज्ड, प्रीफिक्स दिस इज क्लोज्ड, सो ट्रिक मतलब क्लोज्ड, suffix not closed, substring no, substitution no, this one is closed, and clean star closed, subset not closed, prefix, suffix, substring, substitution and everything. So बहुत easy है CFLs को रिमेंबर करना, राइट। DCFLs को भी रिमेंबर करना बहुत easy है, क्यों, प्रीफिक्स क्लोज्ड एंड इनवर्स होमोमॉर्फिज्म क्लोज्ड, इससे पहले कॉम्प्लीमेंट क्लोज्ड। बस तीनों ऑपरेशन है DCFLs के लिए वो जो क्लोज्ड बताया इस 12 ऑपरेशंस में। दिस 12 ऑपरेशन, इन दिस 12 ऑपरेशंस ओनली 3 ऑपरेशंस वी सेड क्लोज्ड फॉर DCFLs। ठीक है, नॉट क्लोज्ड भी इनके लिए बहुत कम है, तो यहां पर सबसेट है, इससे पहले इंटरसेक्शन कॉम्प्लीमेंट थे। शॉर्टकट भी आप यूज कर सकते हैं इसको याद रखने के लिए, बट पहले कोशिश कर लेना व्हाई दे आर क्लोज्ड नॉट क्लोज्ड। मोस्टली गेट एग्जाम में नहीं पूछेंगे वाई क्लोज नॉट क्लोज, एमटेक लेवल में पूछेंगे, और नहीं तो कभी इंटरव्यू में गया तो वहां भी पूछने के लिए चांसेस है। बट गेट एग्जाम के लिए ये टेबल एनफ होता है। और हाँ, मैं तो कोशिश किया मेरा टाइम में रिमेंबर करने के लिए, मेरा से नहीं हुआ तो आज याद रख सकते, कल भूल जाओगे, क्यों इतना सारे चीज दिमाग में बिना रीजन के साथ याद रखना मुश्किल होता है। ठीक है, कोशिश कर लेना, बट हो सकता कल, आजकल याद रख सकते, परसों भूल जाओगे। ठीक है, बट ये शॉर्टकट याद रख सकते। फॉर DCFLs के लिए आप ये याद रखना, क्लोज्ड वंस क्या क्या क्लोज्ड है, कॉम्प्लीमेंट, प्रीफिक्स एंड देन इनवर्स होमोमॉर्फिज्म। रिमेनिंग ऑल आप बोलते ये क्लोज्ड है, बहुत इजी याद रखना। फॉर CFLs नॉट क्लोज लिस्ट याद रखना। नॉट क्लोज में क्या क्या है, सॉरी ये है इंटरसेक्शन है और कॉम्प्लीमेंट भी है। कॉम्प्लीमेंट होगा तो डिफरेंस भी होता है। ठीक है, नॉट क्लोज में डिफरेंस भी आएगा। और सबसेट, सबसेट तो सबके लिए नॉट क्लोज थे। ठीक है, और कोई है क्या, ये नॉट क्लोज्ड जो लिस्ट दिया है, ये नॉट क्लोज्ड फॉर CFLs। ये भी एक शॉर्टकट है, आप ऐसे भी याद रख सकते हैं। यार मुझे याद ऐसे नहीं थे, मैं हर ऑपरेशन को एनालाइज किया है, इसलिए मुझे याद रहता है। अभी हर ऑपरेशन को हम बहुत ज्यादा डिस्कस नहीं कर सकते ना, तो मैं याद नहीं रखे यार, मैं रीजन के साथ याद रखा था, रीजन मैं नहीं बता रहा है, क्यों, टाइम आपके पास कम है। अगर रीजन को हम स्टार्ट किया है, यही 3-4 घंटे चले जाएगा और डीओसी जल्दी कवर करना आपके लिए दिक्कत होता है, ठीक है। यस, CFL कॉम्प्लीमेंट इज नॉट क्लोज, इसलिए नॉट क्लोज लिस्ट में आया। CFL कॉम्प्लीमेंट इज नॉट क्लोज, तो कहा था ना, एक बार फिर वापस जाके देखो ये क्या किया है, कॉम्प्लीमेंट नॉट क्लोज्ड, कॉम्प्लीमेंट नॉट क्लोज्ड, वो भी है, बहुत इंपॉर्टेंट है कॉम्प्लीमेंट भी, कॉम्प्लीमेंट ये भी इंपॉर्टेंट है। CFL कॉम्प्लीमेंट आंसर होता है मे और मे नॉट बी CFL, नॉट CFL नहीं बोलना है। बहुत लोग को दिक्कत होता है CFL कॉम्प्लीमेंट इज नॉट CFL, गलत स्टेटमेंट है, मे और मे नॉट CFL, मे नॉट बी CFL। कभी कभी CFL होता, कभी कभी नहीं होता है। तो कोई भी रेगुलर लेना, देखो A स्टार B स्टार, ये तो CFL है, ये CFL तो है, रेगुलर मतलब CFL तो है। इसकी कॉम्प्लीमेंट करो, वो भी CFL है ना। इस CFL हमेशा नहीं होता है ना। देखो A पावर n, B पावर n, C पावर n, ये जो कॉम्प्लीमेंट है, ये जो है ना, ये CFL है, बट इसकी कॉम्प्लीमेंट जो है इज नॉट CFL। देखो दो कॉम्प्लीमेंट्स है यहां पर, एक लैंग्वेज है, ये जो है CFL है, बट ये CFL का कॉम्प्लीमेंट जो है नॉट CFL है। तो बहुत लोग को ये पता होना चाहिए, सर A पावर n, B पावर n, C पावर n जो है, ये तो नॉट CFL है, तो लिखा है यही तो है, बट इसको कॉम्प्लीमेंट लिखा है, इज नॉट CFL है। तो ये कैसे हो गया, इनकी कॉम्प्लीमेंट जो है A पावर n, B पावर n, C पावर n, ये CFL कैसे हुआ है, ठीक है, ये आपको पता करना है। ये दो आप याद रख सकते, इसको प्रूव भी कर सकते हैं। अगर नोट्स में देखना है तो आप ग्रुप में जाके नोट्स डाउनलोड करके देखो, इसका रीजन भी आपको पता होगा। ए भी CFL है, रेगुलर होगा तो CFL तो होगा, बट इसकी कॉम्प्लीमेंट तो CFL है, ये CFL की कॉम्प्लीमेंट तो नॉट CFL है, तो इसलिए हम CFL कॉम्प्लीमेंट मे और मे नॉट CFL बोलते हैं हम, ठीक। ठीक है, कुछ होमवर्क क्वेश्चंस कर लेते हैं अब। आज इस सेशन में हम क्या किया है, CFLs DCFLs को आइडेंटिफाई करना था, उसको हम कुछ एग्जांपल्स में कवर किया है। और क्लोजर प्रॉपर्टीज जो है, इंपॉर्टेंट क्लोजर प्रॉपर्टीज, यार बहुत ज्यादा टाइम स्पेंड करके कोई फायदा नहीं है, अगर आपको याद नहीं है और रीजन भी यार समझ नहीं आ रहा है तो डिस्कस करके कोई फायदा नहीं, इसलिए मैं टेबल दिया है सीधा, क्लोजर प्रॉपर्टीज। और कुछ एग्जांपल्स में यार ये भी किया है हम, एग्जांपल में और BDA DPDA कैसे कंसिडर करते हैं हम, ठीक है। अब कुछ ऐसे होमवर्क क्वेश्चन है आपको करना होगा, तो सबको करना होगा ये चीज। मैं एक एक लैंग्वेज, इंपॉर्टेंट लैंग्वेज को मैं दे रहा हूं, तो आपको डिसाइड करना होगा ये क्या है, बहुत इंपॉर्टेंट है, एग्जाम में ये डायरेक्टली भी हो सकता। WW पावर R, यार मुझे तो डिस्कस करना बहुत टाइम लगता है, इसलिए मैं होमवर्क देता हूं, ठीक है। ये जो लैंग्वेज है, ये पता है CFL है, राइट, ये क्या है, ये CFL है, मुझे इसकी कॉम्प्लीमेंट चाहिए, ठीक है। DCFL, CFL, नॉट CFL, नॉट रेगुलर, इनकी आंसर भी मैं एक्सप्लेन करने के लिए कोशिश करता हूं। ये CFL है बट नॉट DCFL है ना। इनकी कॉम्प्लीमेंट WW पावर R भी CFL है, इनकी कॉम्प्लीमेंट भी CFL है, बट दोनों नॉट DCFL है, तो आपको चूज करना होगा यहां पर B चूज करना होगा और D, दो ऑप्शन टिक करना होगा यहां पर। MSQ, ये MSQ है। इस टाइप की क्वेश्चंस आप देख सकते हैं एग्जाम में, पर इतना डिफिकल्ट नहीं, छोटी एग्जांपल होगा आपके पास। एग्जाम में किस टाइप के क्वेश्चंस होगा, इस टाइप की, A पावर n, B पावर n सच दैट n ग्रेटर देन और इक्वल 0 और 1 जो भी है, इनकी कॉम्प्लीमेंट क्या होगा, ये बहुत इजी है। अभी रेगुलर होगा क्या, DCFL, CFL और नॉट CFL। ये आंसर होता है DCFL होता है। क्यों होता है? A पावर n B पावर n DCFL है। DCFL कॉम्प्लीमेंट हमेशा DCFL होता है, तो उससे भी आप डायरेक्टली आंसर कर सकते हैं DCFL। अगर DCFL हो गया तो CFL भी होगा, राइट? ये दोनों टिक करना होगा B एंड C। होमवर्क बता रहा हूं, बट फिर भी आंसर अगर फ्यूचर में किसी को आंसर चाहिए तो यही से आपको मिल जाएगी। थर्ड क्वेश्चन, इज डैश रेगुलर को पता होगा, रेगुलर तो नहीं है। DCFL, CFL, नॉट CFL। ये WW जो है वो स्टैक ऑर्डर में नहीं होता, तो ये स्टैक से इम्पॉसिबल कॉन्सेप्ट है। WW बेसिकली कॉन्टेक्स्ट सेंसिटिव होता है, राइट? इनकी एप्लीकेशन भी है। तो WW मतलब ये होता है, अगर यहां डिक्लेयर किया है, यहां यूज बोलते हैं हम, तो ये बहुत दूर भी हो सकता है, बट यहां पास में दिया है। अगर ये डिक्लेरेशन है, प्रोग्रामिंग में एक कॉन्सेप्ट होता है ना, एक जगह में डिक्लेयर कर लेते, दूसरी जगह में हम यूज करते, ऐसा होता है ना, इंट x, और बहुत दूर में हम यूज भी कर सकते, इंट x इज इक्वल 10 मान लो, कहीं पर यूज किया होगा y इज इक्वल x प्लस a। तो ये क्या बोलते हैं हम, ये एक W है, ये जो दिख रहा है ना यहां पर, यार एप्लीकेशन लेवल बता रहा हूं, एक बार दिया हुआ एग्जाम में, ये बोलते हैं W, और दूसरी W यहां पर है। तो दो W का कॉन्सेप्ट क्या है, ये डिक्लेरेशन है, दूसरी W यूज है। तो ये जो कॉन्सेप्ट है ना, ये सेंसिटिव मैटर है, कॉन्टेक्स्ट सेंसिटिव लैंग्वेज के अंदर ये कॉन्सेप्ट कवर होता है, बट ये प्रोग्रामिंग में भी इस कॉन्सेप्ट कवर होता है, बट ये एप्लीकेशन लेवल क्वेश्चन है, ये टिवोसी है। टिवोसी में एक लैंग्वेज बात कर रहा है, बट लैंग्वेज क्या है, ये कहीं ना कहीं यूज होंगे एप्लीकेशन लेवल में। ये फर्स्ट W रिप्रेजेंट करेगा डिक्लेरेशन के लिए, सेकंड W रिप्रेजेंट करेगा बाद में कहीं ना कहीं आके यूज आने के लिए। तो यूज बिफोर आफ्टर डिक्लेरेशन कॉन्सेप्ट है, डिक्लेरेशन बिफोर यूज। तो ये फर्स्ट W बताएगा डिक्लेरेशन, सेकंड W बताएगा यूज। और W कुछ ऐसे W है, या कभी कभी ऐसे X लिखते हैं हम, X कुछ और, सेम होना जरूरत नहीं, कुछ और। तो ये फर्स्ट W डिक्लेरेशन, सेकंड W यूज, ठीक है? ये एप्लीकेशन लेवल क्वेश्चन भी मान सकते हैं आप। ठीक है, क्या है, नॉट CFL है। क्या है, नॉट CFL है। और इनकी कॉम्प्लीमेंट जो है बिल्कुल डिफरेंट है आंसर। WW is dash, DCFL, CFL, रेगुलर, नॉट CFL, ये होगा CFL। जो WW पावर R का कॉम्प्लीमेंट जो है, उनकी रिलेशन है ये भी। यार WW पॉसिबल नहीं है, बट उनकी कॉम्प्लीमेंट जो है नॉन डिटर्मिनिस्टिकली पीडीए डिजाइन कर सकते हैं। यार इसको कोशिश भी मत करना, टाइम वेस्ट होगा आपको। तो 4 कॉन्टेक्स्ट फ्री ग्रामर आप गूगल सर्च में कर सकते हैं, आप पीडीए भी डिजाइन कर सकते हैं, तो बट करना जरूरत ही नहीं है, और उसको आधा घंटा टाइम लगता है उसको समझने के लिए, कम से कम 20 मिनट्स एटलीस्ट। ओके, बट कोशिश कर लेना। इनके आंसर जो होगा CFL, ठीक है, DCFL नहीं होगा, बट कॉम्प्लीमेंट ऑफ WW। ये देखो WW नॉट CFL है, बट WW इनकी कॉम्प्लीमेंट जो है वो CFL है। ये दोनों बहुत इंपॉर्टेंट है, इसलिए मैं होमवर्क में भी दे रहा हूं। ठीक, किसी के पास भी टाइम है, प्लीज ट्राई इट। अदर टाइम नहीं है तो मत करना, एटलीस्ट याद रख लेना। A पावर n ऐश A पावर 2n, n ग्रेटर देन और इक्वल 0, अगर नहीं दिया मतलब ग्रेटर देन और इक्वल 0, इज डैश रेगुलर, डिपेंडेंसी है। DCFL देख लेना होगा नहीं होगा, अगर DCFL है तो CFL होगा, अगर CFL होगा तो CSL भी होगा। CSL नहीं है सिलेबस में, बट फिर भी ऐसे दे रहा हूं, तो यहां आंसर होता है BCD। ओके, ये DCFL होगा। क्यों, एवरी ये आप ऐश से पहले पुश कर लेना, ऐश के बाद उनके डबल आना चाहिए, तो एवरी 2a के लिए 1a पुश करो, है ना। ये आंसर DCFL, CFL, CSL। ठीक, चलो। सो हम अब तक कॉन्टेक्स्ट फ्री लैंग्वेज तक आया, और नेक्स्ट क्लास में ट्यूरिंग मशीन, एंड ट्यूरिंग मशीन में कंस्ट्रक्शन जरूरत नहीं है, फिर भी हम एक दो प्रॉब्लम को कंसिडर करेंगे, बहुत टाइम लेता है, इसलिए हम कॉन्सेप्ट को पढ़ना होगा। तो ट्यूरिंग मशीन अनडिसर्बल में जो जो इंपॉर्टेंट कॉन्सेप्ट होता है हम फटाफट उसको कंप्लीट करेंगे, और आज तक जो भी किया है कॉन्सेप्ट को तो नहीं छोड़ा, जो एग्जाम के लिए जरूरत है, अभी जाके गेट पीवाईक्यूज देखो, बहुत सारे कॉन्सेप्ट हम क्लास में कवर किया है, ऑलमोस्ट मैक्सिमम कॉन्सेप्ट कवर किया है। तो देख लेना, अगर एक दो कॉन्सेप्ट मिस किया है कम से कम पीवाईक्यू से कवर कर लेना। और होमवर्क क्वेश्चंस बहुत इंपॉर्टेंट है, अगर जो मैं नहीं कवर कर पाया तो हम होमवर्क में कवर कर रहे हैं। CSL सिलेबस में नहीं है ब्लू लिस्ट, आप ट्यूरिंग मशीन पढ़ लेना, वहीं पर जो कॉन्टेक्स्ट सेंसिटिव लैंग्वेजेस कॉन्सेप्ट आएगा वहीं पर कवर करेंगे हम, ठीक है। अलग से कॉन्टेक्स्ट सेंसिटिव लैंग्वेज पढ़ना जरूरत नहीं है, जो रेगुलर लैंग्वेजेस है वो कॉन्टेक्स्ट सेंसिटिव है, जो DCFL वो भी कॉन्टेक्स्ट सेंसिटिव है, जो CFL लैंग्वेजेस वो भी कॉन्टेक्स्ट सेंसिटिव है, बट जो ये नहीं होता कभी कभी कॉन्टेक्स्ट सेंसिटिव हो सकता है, लाइक a पावर प्राइम, a पावर n फैक्टोरियल, a पावर n, b पावर n, c पावर n, इस टाइप की लैंग्वेज जो है वो कॉन्टेक्स्ट सेंसिटिव है, तो हम वो ट्यूरिंग मशीन में कवर कर सकते हैं, ठीक है। या देन सी यू टुमारो सेम टाइम 8 AM। तो आप अब तक जो भी हुआ है तो एक स्कैन में कंप्लीट कर लेना फटाफट, और कल ट्यूरिंग मशीन स्टार्ट करेंगे हम, ठीक है। थैंक यू, बाय बाय, टेक केयर।